Hi, in this video I'd like to show you the bare minimum of what we need to know to render a visualization in ggplot. And the bare minimum is that we need to use the 3 essential layers, 3 out of 7 possible. Those 3 essential layers are data, aesthetics, and geom, short for geometries, layers. To do that, I'm going to walk through the code that I wrote to generate this plot here in ggplot where I've used those 3 layers, data, aesthetics, and geom. And this is really for the capital markets line, or CML, but it's a little bit of a cheat because it's just in the 2-asset universe to keep it simple. So I've got a 2-asset portfolio where I plotted here in red that portfolio where the assets are almost perfectly correlated. Then here in blue-green, probably more familiar, portfolio possibilities curve, we call that a PPC, very nonlinear, where the assets are uncorrelated. And then I've used ggplot, and I've added with that geom layer a point here for the portfolio that we would call the optimal portfolio, highest Sharpe ratio, and also a triangle here for the minimum variance portfolio, because it's the furthest to the left on the portfolio possibilities curve, where this x-axis is the portfolio volatility and the y-axis is the portfolio return. And then I added with a geom a straight line here, which we could call a sort of capital market line, because its point of tangency is that optimal portfolio. And so it intersects at the y-axis somewhere down here where we can't see. It intersects at the risk-free rate. But so that's all in ggplot using those 3 essential layers. So here I'll start with an early version of my R notebook file. The R notebook file allows me to run interactive chunks here. And the first chunk in my file is just to show you this image, to give you a taste of the super elegant theory underneath the ggplot. So as we go to build a plot, we can invoke here up to 7 layers in the visualization. So I've got them listed here, but I'm coloring the 3 essential layers that I'm going to use for my 2-asset capital market line plot that I'm going to show you. But this ends up being super powerful because we can use this geom layer, for example, multiple times as we build and modify the plot. Further, as we add layers, we can store this as work in progress as an R object for edit or later reuse. Each of these layers has its own functions with arguments. So this ends up being not only logical, but super powerful in terms of what seems to me to be an almost infinite permutation as to how we render the visualization. Okay, so aside from that universe of infinite possibilities in this 7-layer logic, what I've just colored here are the 3 essentials, which are easy to use. And so we do need, under here at first layer, we need a data layer. Of course, we need to provide ggplot with the data that we are going to plot. So this will be a DataFrame, or in the tidyverse, that'll be a tibble. And then really we just need an aesthetics and a geom layer. The aesthetics is where we decide which variables in our data we're going to map to aspects of the plot. And then the geom controls the specific manifestation of that visualization. Are we going to see, do we want points, for example? Do we want lines? Do we want bars? Right? So the geom visualizes the mappings that to variables that we specified in the aesthetics. And that's the 3 essential layers that although I'm still learning ggplot, once I started got comfortable with that, geoms and aesthetics, I started to feel a lot better about my use of ggplot. And then here I have a typical example that's in several textbooks. And this is using the MPG dataset that's built into ggplot. And you can see here's a little partial view of that data frame. And so it's fuel economy data from 2 years, 1999, 2008, for various models of car. And it can see my data frame over here. If I click on this, I'll get a view of it. And so I'm going to do a very typical use of this data frame, and that is to explore, let's just say we have a theory that engine displacement has some relationship with fuel efficiency. That's this column here. HWY is the variable for fuel efficiency. This is miles per gallon. I think this is in liters. And so we just want to do a scatter plot. So we've got a whole data frame here with 11 observations, or not observations, sorry. The rows are observations. I got 11 variables or features in columns. So I'll give the data frame to ggplot, but in my aesthetics, I need to decide which variables I'm going to use and map them. So I'll use the ggplot, and then the first argument is my data. So I don't need to specify data, but I'll just do it explicitly. That's my first layer already, the whole data frame. And now I need to do the aesthetic mapping. And that's where I decide that to the x-axis, I am going to map my displacement variable. And to my y-axis, I'm going to map my fuel efficiency, HWY. And then I think I can go ahead and run it, because I do actually have a valid ggplot object there. Here's my first layer, my data frame, and here's my aesthetic layer, where I've made that decision to map my displacement variable to the x-axis and my fuel efficiency, I'm just going to call it fuel efficiency, to the y-axis. And ggplot did go ahead and generate the plot for me, but I haven't defined that third layer, the geom. I haven't really decided, do I want points or something else? And points, of course, seems very natural here. So we use geom, and geom then underscore, and we start to get a hint here at really how many geoms are built into this. Super cool. There's so many. Haven't even begun to explore them all. But if we go geom point, very intuitively labeled, and now I rerun, and I get here classically scatter plot. It looks like I do have an inverse relationship between fuel efficiency and engine displacement. And then what you'll also see is we can go back and decide to do an additional mapping, because after all, X and Y are just, let's see what I'm going to call them. These are just aspects, but they're not the only aspects. I can actually map to color the cylinder. So we had 4, 6, 8 cylinders, S, Y, L. I've now mapped that third variable to color in the aesthetic layer. And then if I run that, points picks it up and is treating it here as continuous, but you can see it is distinguishing, and I do see a pattern there. So it's continuous there, and I could force it to be a factor or categorical variable, make sure I get the number of parens right, rerun it, and now it's treating it as a categorical, you can see. So I'm getting my cylinder as the third variable here that's in the mapping. So I've taken that data frame mapped to display to x-axis, to y-axis, and to color. So that's the basic example. But now let me show you my 2-asset capital market line plot. And then just some, I'm going to make sure I've got dplyr run. And then here I've just set some variables. My risk-free rate is going to be 6%. And then right here, I'm going to have 2 assets. So I've got the return of asset A and the sigma of asset A. So that's my standard deviation or volatility. So here I've got asset A has a 10% return and a 10% volatility. And then asset B is going to be my higher risk, higher return asset, 16% return with 16% with 20% volatility. And so I'll just run those, and they show up in my environment here as values. And then what I've already pre-coded are 3 functions that I've just written that I'm going to call later. And my first function here is just going to return a portfolio data frame. So this function is going to accept the vector of weights for asset A, and then also the other characteristics, asset A return, asset A volatility, asset B return and volatility, and then the correlation between them. And then I don't need to accept the the weight of B, because the weight of, in my two asset world here, the weight of B is just going to be 1 minus weight of A. And then for students of finance, these formulas will be very familiar because we're in the classic mean variance framework here. So I pass to this function these arguments so that I can compute here a portfolio return. And so you see I've called that return underscore AB to indicate that it's the portfolio return, which of course is just the weighted average of the component returns. And then here in that mean variance framework, I've calculated the portfolio variance, sig squared AB, and then the square root of that then is my portfolio volatility. And then the point of the function here is to just generate this portfolio data frame. So you can see here it defines a data frame. And I'm going to get back here a data frame, which is the vector of all of the weights that we want to allocate to asset A. And then for each of those rows, the portfolio return and portfolio volatility. So that's the point of this function, is to return for me a data frame that gives me the portfolio characteristics here in the mean variance framework, portfolio return, and portfolio sigma. Then my second of my three functions here is an analytical function that solves for the highest Sharpe ratio. So we would normally call that the optimal portfolio. And then if this were in the n asset universe, this would be the market portfolio. But in the two asset universe, it's just the portfolio of two assets with the highest Sharpe ratio. And for the Sharpe ratio, of course, normally we see that as a solved for or simulated result. But this two asset universe is relatively simple, such that we can actually retrieve the analytical solution. It's a not too difficult solution to a calculus problem. So optimal weight will then return for me, if I give it the other parameters, the weight that I want to allocate to asset A in order that corresponds to the two asset portfolio with the highest Sharpe ratio. And then finally, I have the minimum value portfolio. So this is similar. Unlike the Sharpe ratio, it doesn't need the returns. It only needs the volatilities and the correlation. And in the two asset universe, it's a very simple to find the minimum variance portfolio. And that's all this function is returning. So the notebook allows me to just collapse those three functions, and I'll run them. So you can see they're over here for later reuse, although I've uncollapsed them and running them, I suppose. So then I can go and generate my capital market line now. Okay, so the first thing I'm going to do, you can see here, is just generate a vector using the sequence command. This is very straightforward. The vector W underscore A is just a vector running from 0 to 1 by 0.05. So this is really the weight, this is the vector, the possible weights I'm going to assign to A. I could have gone negative, and I could go negative with lending, right? And I could go above 1 with borrowing, but I'll keep it into the 0, 1. So we're waiting. We're going to look at the possibilities from 0% to asset A up to 100% to asset A. And I've just decided arbitrarily to go in 5% increments. So that's all that does, is define that vector. And then I'm going to just generate the data frame that will allow me, that really constitutes the data for what we call the portfolio possibilities curve, right? So I'll just define this as portfolio where the row is, or row standing for correlation, is 0. And then here for the assignment, I learned this from Matt Doncho's excellent course. I only started the first course, but I already learned something really cool that I didn't know. I could just do Alt dash, allows me to, is the shortcut for the assignment there. So to that variable, I'm going to call the function that I've already created for the portfolio return, and I'm going to feed it the vector that I just created of weights allocated to asset A. So that's that vector there. And the rest are really just going to be my values. Return on asset A, volatility on asset A, return on asset B, volatility on asset B, and finally the row, the correlation between the two. And in this one, per the label, I'm going to use a zero correlation portfolio. And now let me just show you that, right? Because in that function call here, this really is the only vector, but are so elegant that that function returned for me here a data frame with the 3 columns. So, and I love this feature in our studio because those of us who come from the Excel world, we love to look at our data that way, this way in an Excel format. So here I'm seeing the data frame in a very comfortable setting for me as an Excel person. Here I'm getting this first column. That vector corresponds to that vector of weights on asset A. You can see starting here at 0, going down to 100%. And then the function return for me, this is portfolio return and portfolio volatility. If we have, let me just take this row here, this would be the 2 asset portfolio with 20% to asset A and therefore 80% to asset B. And that portfolio, again, I made this function call assuming a 0 correlation. So that portfolio, that 2080 portfolio, has a expected return of 14.8%, and you can see a volatility of about 16.12%. And so that's my data frame that I'm going to use for the ggplot. But before I do it, I'm going to run it once more. And the only thing I'm going to change here is I'm just going to do a highly correlated assets. So everything else is the same. And this time I'm just going to pass as the correlation argument a 0.8. I always want to say 80%, but I have to remind myself that correlation is a unitless number. And one of my customers many years ago corrected me and said, Dave, it's not 80%, it's unitless, it's 0.8. Never forgot that. It's been like 8 years later. Okay, so now I've defined another data frame. You can see here, structure is going to be exactly the same, but this is for my 2 asset portfolio where the assets are highly correlated, very highly correlated. Okay, and then so this is the essence of what I wanted to show you. And I could go right to a ggplot to plot it, but again, part of the whole elegance of this is that I can right away go and store my plot as an object. I think of that as storing the work in progress. So this might not be the best way to use ggplot, but the way that I've been doing this is, as I iterate, I sort of store it to a variable as an object so I can retrieve the version of the ggplot at that point in time. So here I'm going to call this P1, and then I'm going to do my ggplot, which, as we know, the first layer is the data. And so that the first argument is data per the data layer. And so at this point now I know that I don't need to be explicit about that argument. And so I'm just going to use that first data frame I created where the correlation is 0. And then the second layer is the aesthetic layer. And now I need to decide which of these variables I'm going to map. And what I'm going to do is I'm going to map to the x-axis my volatility. I don't want the sigma function. And to the y-axis, I'm going to map my return, because that's really what I'm going for in this capital market line. And so far, I've used the first 2 layers, right? Data and aesthetics, and then I'm just going to finish with the third layer, and I'm going to use geom path here because I could use points, but I'm going to connect the points, so to speak, with a path. Control Enter, and it doesn't appear right away because I've stored it, you can see here, as P1, and now I'm just going to print P1. And there we go. And then we call this in the mean variance world the portfolio possibilities curve, right? Each of the return that corresponds to the portfolio volatility here. If we look at it vertically, if we slice it vertically, any point here dominates any point here because for the same volatility we're getting higher return. So the upper segment is called the efficient frontier. And then at this point, then now we're going to look for, I'm going to use those functions because there's two obvious points of interest here, the minimum variance portfolio and also the optimal portfolio with the highest Sharpe ratio somewhere up here. But before I do that, in this geom, I'm going to kick this down here. In the geom, I have further arguments. For example, I can say, let's make the line red, and let's make the line type dashed, right? Rerun, and I get that different version. But these aren't really variables. These are really attributes that I specified in the geom layer here. But if there's anything I can impart in this video as far as an introduction, is that that's the essential structure of the ggplot. And this is the sort of the structure that I've been practicing and trying to get familiar with. Just this fact that we call the ggplot, we have a data layer, the aesthetics where we map the variables, right? Sigma and return are variables, they're not really attributes. And then that third essential layer is where we decide visually, how do we want these mapped variables to appear. In this case, it's a geom path as opposed to a geom point or a geom bar, and we can specify the specific attributes of that geom further within the geom path. Now here, this next step, when I did it, frankly, I didn't expect it to work, and then I had to go back and sort of learn more about the super elegance of ggplot, and that is that we can add additional geoms at this point. This is really cool just by itself, but I can also go and feed this additional geom layer a new data frame because I have a second data frame here. It's that portfolio, right, where the correlations are 0.8 instead of 0. But that data frame has the same structure and therefore the same variables. And so ggplot is smart enough to accept it. And in this geom here, so I've actually swapped out the data frame is how I think of it. And I could, and so if you're wondering, well, could I have done another aesthetic? Yes, I could. I don't need to. But I will change the attribute here. I'll go from color to blue. And so this is when I first did it, I just suddenly started to realize how super powerful this ggplot is. And so then if I rerun that, you see I'm getting two portfolio possibilities curve. Dashed red is my zero correlation, a little bit more familiar shape. But then I added another geom layer here with my highly correlated portfolio. Assets A and B are otherwise similar. So this is a logically valid representation because all I've changed is the correlation. And this is, as you probably know, a perfect correlation would be a straight line. So this is getting closer to the straight line. Now, real quick, I'm just going to do one thing to re-represent that. I think it's possible that some would say this is not a very elegant approach to cast new data into this geom. And that's because my data isn't really tidy, but I could make it tidy. And what I could do here is define P row both. What I'm going to do is combine the two data frames into a single data frame. And I'm just going to use the R bind, which allows me to bind the rows so they have the same structure. So I'm literally going to glue my second data frame to my first data frame. So I really just need to give it the two data frames, but I'm going to do an interim step here with dplyr, and that is, if I just glue them together, I'm not going to be able to tell the difference. So I'm going to add a column right before binding them. So I'm going to bind P, I'm going to bind my first one, but I'm going to add this column type, and where it's Z just because that has a 0 correlation. And then I'm going to mutate the second. And I'm just going to call that type 8. So all I've done there is I take each of these data frames, and mutate just allows me to create a new column, so that in this data frame I have a column with type called Z, and in this one, so the combined data frame will have a type column, but I'll have a way to distinguish here between which is generated from the 0 and which is generated from the 0.8 correlation. And then I'm just going to finally pipe that and arrange it by weight, so that if I run that, and if I just show you the return both. So I do have two data frames, each of the 21 observations for each of the correlations, but then I've just created a combination here. This has 42 rows, so you can see, but arranged by weight. So now I have two rows at weight 0, 2 rows at 5%, where here my first row you can see is the portfolio 0 correlation. My second row is the portfolio 0.8 correlation. Then I go to the next weight, 5%. I have 2 rows, first for the 0, then for the 0.8. So I've taken the 2. I have one data frame that's double the size. It's sorted by weight, but the whole point of this was that I inserted a type column so that I can now distinguish them with this variable type. So the reason that I did that is just to go back and say ggplot. Now I'm going to use both the combined data frame, and the aesthetic is still going to be sigma to the y-axis, return to the x-axis. And now I'm going to map a third variable. I'm going to map color. I'm going to map the type variable that I created to the color. So I wanted to show you what this is, arguably a more elegant approach to using the ggplot. And the more elegant approach in general implies that I wrangle the data, or shape the data, I probably should say shape the data, before I use the ggplot in a way, shape the data knowing how I'm going to look at the data. And this allows me to be more logically consistent in using my aesthetic layer on the single data frame to map this third variable type. And then in this case, I'm just going to call geom path by itself, my P2, and if I call that, I didn't override any color there, but you can see I get to similar effect. But this time I've handled it with a single geom path and mapping with a third variable. So that was the point of that. I could very briefly here. I'll show you my initial visualization of the 7 layers, including the facet layer, because that's after the essential 3. That's the one that I've been practicing most with, the facet layer, because it gives us the ability to act in add an additional dimension quite easily. So in this case, for the ggplot, I'm going to pass this the data p row both, my aesthetic h equals sigma, y equals return. Okay, finish that. Then I'm going to do geom path. And that's my 3 essential layers. But now I'm going to add the facet wrap. And I just need to specify how do I want to facet this. I'm going to facet it by the type that I've created, and I'd do it by rows as opposed to columns. So n row equals 2. That's my P3. If I take a look at that, now I've got not a great chart, but that was the same data frame that combines both portfolios, correlation 0 and 0.8, but I faceted them by type. So in the upper facet here, I'm getting the by type where the correlation is 0.8, and in the lower facet, I'm getting the 0 correlation portfolio. So just another way to look at it. And then, but now let me just finish by going back and adding the optimal portfolio and the minimum variance portfolio. So for this, I'm going to say my optimal weight. I'm going to call my function, and my function has return A, sigma A, return B, sigma B, and I'm going to do it for the 0 correlation portfolio. That called my function and got me the weight to asset A that corresponds to the 2 asset portfolio with the highest Sharpe ratio. And then I'm going to retrieve that portfolio's characteristics with my R_P function using that weight. And it needs return A, sigma A, return B, sigma B, and again for the 0 correlation portfolio. So that P market now, it does return a data frame, but it's a single data frame corresponding to that optimal weight that I fed. So this is the optimal portfolio has this return and this volatility. So that, now I'm going to do P4. I'm going to go back and use my P2, which is my ggplot. It's an object. It's a list object. And I'm just going to add now, because I've already got the portfolio possibilities curve in that P2. All I need to do is add the point for the optimal portfolio. And so now my data is, right, portfolio market, right? That's my first argument. I could have said data equal. That's my market portfolio data frame. And my aesthetic is same as it is on the P2 plot, x equals sigma. Well, I'm just going to be formal about these arguments. Y equals return. And then I'm going to use, I'd like to really emphasize this point. So I'm going to say size equals 4 and maybe color equals purple. And I get an error. And that's because I didn't finish my point. Still get an error. Let me go back here and just be real formal about the data equals P market. Aesthetic equals x equals sigma, y to return. That looks good. Size equals 4, color equals purple. That looks okay, and it is fine. Okay, so then I look at P4, and it's plotted my highest Sharpe ratio portfolio here as a purple point. Pretty cool. So now I'm going to illustrate the capital market line, or really not the capital market line, but in this 2 asset universe. So P5 is going to be P4 plus, and then I've got the geom ab line, which allows me to draw a line. And of course, it helpfully lets me define the line in terms of an intercept and a slope. So my intercept here is going to be the risk-free rate, how convenient, and my slope, Well, what's my slope on the capital market line? It's the Sharpe ratio, rise over run. So for my numerator, I'm gonna put this in parens. I want P market return. Whoops. Get that back. P market return minus the risk-free rate divided by, that's my excess return in the numerator, divided by my volatility in the denominator. So that is not only the Sharpe ratio, but as the Sharpe ratio of the optimal portfolio, it's the slope of the capital market line. Okay, so that looks good. And let me see if it plots. And it does plot. You can see it's the point of tangency is the optimal line, and then the intercept here is going to be in the risk-free rate, although it's off the chart, but no worries. I could rescale the X, but actually before I do that, let me plot the minimum variance portfolio. So I do need the weight of that portfolio, but I wrote that function right to solve that for me above, and then I called that W underscore MVP. If I had forgotten, I've got my environment here that would remind me, there's that function I defined earlier. And my MVP function, let's see, it only requires it doesn't need the returns, it just needs the volatilities, sigma B rho, and the correlation AB. I'm going to specify that explicitly as the zero correlation portfolio here. Yep, didn't do it that time. Okay. And so then I'm going to retrieve the portfolio characteristics of that minimum variance portfolio now that I have solved for the weight and stored it to that variable. Calling my function, my return portfolio function with the weight that I just solved for, return of A, sig of A, return of B, sig of B, and rho AB equal to 0. Okay, that gives me the portfolio, and now I am ready to plot it. So P6 is going to be P5 plus a point, a nut. So I'm adding, let's see, I guess this is the, I had a layer for the portfolio possibilities curve. I had a geom for the optimal portfolio. Now I'm adding another geom and storing into this P6 to represent that single point of the minimum variance portfolio. So my data here is my minimum variance portfolio. It's a data frame with only that single row. I'm going to go ahead and redefine the aesthetic here, or be explicit about it. X sigma equals return. And my size on this, let me just make it 6. And let's see, my color, just going to make it orange. And just for fun, I'm going to give it there's a shape argument. I'm just going to give it shape 17. And let's graph that. P6, and there we go. I'm getting the minimum variance portfolio. Here's a big orange triangle. Here's my optimal portfolio. And the only thing I might still want to do is rescale this. So I can add a scale, X, continuous, where my limits are defined here, 0 to, let's say, 0.2. So I took it out a bit, not optimal, but you get the point. I could also scale the y-axis, and while I'm here, I could also just quickly apply. Now I'm reaching out for that another among those 7 layers, the theme, built-in themes. I could just borrow the classic theme. You can see it took away the background, makes this quite a bit more readable. Just using the built-in construct of the classic theme, and there are lots of themes. So that's my CML line, and that's my introduction to ggplot. Just remember, again, we do have the 7 layers. I found it myself. I continue to spend some time just on mastery of these 3 essential layers: data, aesthetics, and geom. I hope the video is helpful. If it is, of course, I'm going to ask you to subscribe to the channel. I'll see you in the next video. Thank you.